right? So we have a store that's selling sweets for $100, which consists of a hoodie. Sorry, sweatsuits. What am I saying? Consists of a hoodie. So you've got 4 options there and a pair of sweats, black or gray. How many different combinations are there? And really, you just take the event, right? You've got 4 options there and 2 options for the sweatpants. That'll be 8 options. So you can write down 8 options, 8 combinations, something like that when it comes to word problems. How many combinations are possible if you want black sweat? So if you just want to stick with that, so that'd be 4 times just 1, right? You only have 1 option for that second, so it's 4 options. It's okay if you don't have units today. How many combinations are possible if you want a red hoodie? And so if you want the red one, so that means that the first event just has 1 choice and you've got 2 for the second. So it'd be 2 options. Next, a different scenario. For a game, you toss a coin and roll a 6-sided die. And so the coin we know has 2 options, right? How many different combinations are there? So it'd be 2 times 6, so that'd be 12 combinations. How many combinations are possible if you roll a 6? So it's basically saying, hey, if this is 6, what options do you have for that? It would just be 2 for the coin and then just 1 option because you rolled a 6, that'd be 2 combinations there. How many combinations are possible if the coin lands on heads? Well, that means that for the first, you don't really have a choice. It is the 1 is heads, and then 6 for the die, so it'll be 6 combinations. 1 each question right now, 1 mark for each question. How many combinations are possible if you roll an even number? So you have 2 heads and tails, but you only have 3 options, right? That's where the action is at on that second event. Half of them, right? So that'd be 6 combinations. So there you have your 1 mark each so far. Keep going. Computer program generates 4-letter passwords. How many combinations are possible given the following criteria? I was hoping, right, that you know that 26 letters available. Later on, maybe I did it in the notes already, special characters come in, even lowercase, uppercase. Like if this had said the password is case sensitive, technically you have 52 options in this case, right? Because they count as different characters. So no restrictions whatsoever. You can use the fundamental counting principle, right? It'd be 26, 26, 26, 26, right? So you can repeat. So it's 26 to the power of 4. And that's really 456,976 passwords that can be made with no restrictions. No letters can repeat, right? So it's 26, 25, 24, 23, right? So every event has fewer options as you go down. So that's 358,800 passwords. Password must start with a Y. So that means that your first letter is a Y and there's just 1 option. It doesn't say, so you gotta have to reset. Okay, 10 doesn't say whether or not you're allowed to repeat. So we're assuming you can repeat. So I hope that that part you understood. So it's really 1 times 26 to the power of 3. And that is 17,576 passwords. 1 mark for each still. Passwords must start and end with a Y. So you've got a Y at the end, a Y at the end, and the start. So you've got 2 slots to fill. That's 26 times 26. So this is really 26 squared, which is 676 passwords. Okay. So I'll give you another context, right? Like if you peek on somebody's PIN code as they enter it, So let's say you caught it that somebody had a Y and a Y like this, right? There's really, like, you narrow down the options for guessing, right? So this is what's happening. If you only caught one, right, you'd have quite a bit more. If you know two of the password, the letters, then it's only 676 guesses that you have to make. Okay. Passwords must end with a vowel. I don't know if you knew what a vowel was. I was hoping. A-I, A-E-I-O-U. Right, so we've got 5 options there. It doesn't tell us whether or not we can repeat, so we're just assuming you can. So this is really 26 to the power 3 times 5. So it's this number times 5. And that's 87,880 passwords. All letters are the same. Here I'm interested to see what you put down. And the way it goes is, let's say you chose all of them to be A. So it'd be 1 times 1 times 1 times 1. So it's just one password, right? But you can make how many of those? You can make 26 of those, right? So if you want to just take that whole thing, go times 26, there are 26 passwords available for you to make. So you have to consider that case that you all of them can be B, C, D, and so forth. So it's 26 passwords. First letter is either a T or a D with no vowels. How did you interpret this? What I was trying to say here is it starts with this and this, and the whole password cannot have any vowels. That's what I was trying to say. Okay, I hope so. You decide how you want to show your work. I'm not sticky on this is how you have to do it, but some students prefer saying, hey, I'm going to go with the T and the D like this. I'm going to split it up into cases. Dun, 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 dun. And I'm going to add it up later. So if there's no vowels, 26 minus 5, that's 21 options, right, per event. So it's 1 for the T, and then it's 21, 21, 21, and same thing here. And so that's 21 cubed, and this 21 cubed. I don't have it. I have just the final answer, guys. So I'm just going to give you the answer. It's 18,522 passwords or combinations. So this would be a +1 if you get the bonus right. But I would argue you have to have it exactly. You would have to have exactly this as your final answer. You will see me on keys and stuff for time purposes. What I do is I will say T or D like this, and I'll say there's 2 options, and then I'll say, right, next is like this, and you can tell that you're going to get the same answer. You're basically multiplying 21 cubed times 2. Right? So that's how I tend to solve these to just save time. Okay, what are we at? 13, possible 14, but it's out of 13. So go to the top. I think this wasn't too extravagant, but at the same time, I want to make sure, like, where are you at? And then we'll move forward. Okay. So if you could pass this